Today we're going to learn how to solve a system of linear equations graphically. So you should be on page 33, and this is day 8 of the coordinate geometry packet. Okay, so a system of linear equations just simply means two lines, two linear equations, so two lines. Let's just jump right into this. Exercise 1. Consider the system of linear equations shown below. The graphs of both linear functions are shown on the grid at the right. So y equals x plus 2, it's labeled, and here's that line, and y equals negative x minus 4. That's that line. What point lies on both lines? Well, if I have two lines and the same point is on each line, that's called the point of intersection. It's where the two lines cross each other. So we're going to name that line. So in order to get there, we start at the origin and go left, 1, 2, 3, so negative 3, and then down 1. So that's negative 3, negative 1. Okay, so part B here, let me scroll down. Part B says, algebraically justify that the point from part A is a solution to the system of equations by checking to see if the point satisfies both equations. Satisfies both equations simply means substitution. We're going to substitute in the x and the y values of the coordinate pair into the two equations that were given. So if you look above, it's y equals x plus 2, and the second one was y equals negative x minus 4. So we have an x value of negative 3 and a y value of negative 1. So that's going to be negative 1 equals negative 3 plus 2. And let's just do this one completely. Negative 3 plus 2 is negative 1. And that's negative 1. So that one checks. And the second one, we're going to do the same thing. The y value is negative 1 equals, and that's a negative x. So we have to be careful of that. It's negative of negative 3. Okay, so the x value is negative 3, but there's a negative on the x. So it's negative 3 minus 4. So negative 1 comes down equals a negative, so a double negative is a positive. That's positive 3 minus 4. Because 3 minus 4 is negative 1, so that one checks. So to algebraically justify that the point is a solution to the system of equations, we have to do two checks. We have to check each equation. Exercise 2. Solve the following system of linear equations by graphing each line. So we're going to graph each line using the slope-intercept, y-intercept method, and then check your solution. Okay, so the slope-intercept method means we have to get this y alone. So let's rewrite this. We're going to name that number 1, and we'll do number 2. So number 1 says y plus 2x minus 5 equals 0. We want y to be alone, so we're just going to circle that, and we're going to get everything else over to the other side of the equal sign. So in order to get rid of a positive 2x, we're going to have to subtract 2x on both sides, and we would end up with y minus 5 equals negative 2x. In order to get rid of negative 5, we have to add 5. Inverse operations. And when I add 5 to this side, I get 0. So just the y comes down, which is what we wanted. And over here, we'll have a negative 2x plus 5. They are not like terms, so they're going to just be rewritten. Negative 2x plus 5. Okay. Next, we have our second equation, which is y minus x equals 2. And we're going to do the same thing. So we're going to get everything that isn't y to the other side of the equal sign, which is just this negative x. So we're going to add x to both sides. And we would have x plus 2 equals y. Okay, once we have those set, we can graph the lines. So we have a line with an m value of -2 over 1 and a b value of 5. So we're going to begin at 5. 1, 2, 3, 4, 5 on the y-axis. Begin at 5, and we're going to go down 2 over 1, down 2 over 1, down 2 over 1. And I think that's enough to create a line. So use your straight edge. We're going to connect these points. And we're going to need some arrows at either end. And we're going to need a name. So the name that we're going to put on this is our original equation. So it's y plus 2x minus 5 equals 0. Okay, same thing for the second one now. So it's y equals x plus 2. Well, our m value is going to be 1, or 1 over 1, because we do need a rise over run. And our b value is going to be 2. So we're going to begin at 2 on the y-axis, y-intercept, and we're going to go up 1 over 1, up 1 over 1, up 1 over 1, and I maybe could go down 1 over 1. Okay, and now I can create the line by connecting the points. Okay, and I need arrows at either end. And I need to name this line. So this line's name is y minus x equals 2. Okay, the next thing is to actually solve the following system of linear equations. So to solve means to find the point of intersection. Please write this, because this is something people forget. They do all that graphing and they forget to actually answer the question. So the point of intersection is here, POI. We can circle it so that we can show that we know what it is. And now we name it. It's from the origin, we're going to go over 1 and up 3. So the name of the point of intersection is 1, 3. You must have parentheses in order to name that point, or else you're going to get a point off. Okay, so that's solving it. The next part is to check it. So I'm just going to bring this down a bit. Okay, so to check it, we're going to rewrite each original equation. So one was y plus 2x minus 5 equals 0. And the second one was y minus x equals 2. In order to check this, we do not have to have y alone. And I want you to use the original equation, because if you made a mistake in getting y alone, you might catch it here. So we're going to use x equals 1, y equals 3. So we have a 3 plus 2 times 1 minus 5 equals 0. So 3 plus 2 times 1 is 2. 3 plus 2 is 5, minus 5 is 0. So 0 equals 0. So that checks. The second one would be 3 minus 1 equals 2. Well, 3 minus 1 is 2, and 2 equals 2. And just to remind you, we're getting those xy values from this point. We're substituting the point into both the equations to check to make sure that they are actually the point of intersection. Exercise 3. Which of the following is a solution to the system of equations consisting of y equals 4x plus 11 and y equals negative x plus 1? So we have two equations. That's what makes it a system. Let's call them y1 and y2. Okay, so I'm going to use my calculator to solve this. And there is more than one way to do this, but one of the ways is to take your xy value and substitute into each of the equations. But there's 4 choices. That's going to take a while unless you get lucky and it's choice 1. So how about this? Let's try putting it in our calculator. 4x plus 11. Y equals 4x plus 11. And the second equation is, so you're going to arrow down and you go to y2, and it's negative x plus 1. Negative x plus 1. Okay. And I can look at the graph, and if I hit Zoom 6 will always give me that squared off window that for now I'm going to be happy with. Well, there's the point of intersection, and if I just estimate it here, 1, 2, negative 2 something, negative 2, 3. Well, look at your choices. There's only one that has a negative x value, so some might call this cheating. I call it using your resources. The answer is negative 2, 3. It's a multiple choice. How'd you get your answer? Nobody has to know. So use that at calculator. Know how to use it. Okay, exercise 4. Use your graphing calculator to set up an XY chart for the following two linear functions. Then solve the system of linear equations. Okay, so we have number 1, number 2. And I just want to point out, solve the system of linear equations means find the POI. So that's important that you note that. Okay, number 1 is 2y minus x equals 8. That's our first equation. In order to put it into the calculator, it has to read y equals. So we're going to add 8x to both sides. We're trying to get y alone. And so that's going to be 2y equals x plus 8, and we're going to divide by 2 everywhere. And we get y equals, well, this technically is 1x over 2. We kind of take the fraction off of the x, and it's 1/2 x plus 4. Okay, that's the first one. The second one's going to originally be 3y minus 5x minus 5 equals 0. And again, we want to get this y alone. So I'm going to add 5x to both sides. And I get 3y minus 5 equals 5x. I'm going to add 5 to both sides. And I get 3y equals 5x plus 5. And now I still have this 3 attached to y, so I'm going to divide by 3 everywhere. Okay, so we're going to divide the 3's, and we get a y equals, and it's 5/3 x plus 5/3. And we could graph this, but a y-intercept of 5/3, I don't know, just doesn't look like something I want to do. So I'm going to go to my y equals, sorry, I already pushed it, y equals, and on my first equation I have 1/2, I'm going to put it in as 0.5, 0.5x plus 4, and the second one is, so I'm going to arrow down, is 5/3 x plus 5/3. 5 divided by 3 in parentheses with an x plus parentheses 5 divided by 3. Close parentheses. And I'm going to look at the graph quickly only because I want to get an idea of where this point of intersection is. So it's at point positive something, 2, 3, I don't know. Let's look at the table and see if we can't figure it out. Okay, so we have x and y, negative 2, 3. Well, we want positives. Okay, 1 and 4.5. That's a point on the first line. But when x is 1 on the second line, it's 3.3 repeating. But look at this one. X is 2, y is 5 on the first line. When x is 2, y is 5 on the second line. That's the point of intersection. All you need to do is find the matching y. So your answer is 2, 5. Make sure you have parentheses around that, and you are done. Good job. I would like you to do number 5 only because it's the same exact type of problem that we did yesterday in class. So just continue on and do that one, and you'll be done for the night. Okay, great job. Thanks.